All right. Now that we have our image shuffling part, we can start shuffling pixels. This is the point of the sequence here. I'm going to be creating a thing that that moves on the pixels individually in a quick way, like an index map. It tells you where each pixel is supposed to go. This will help us do image convolution and all the other stuff that normally is very slow in pixels. Okay, let's just see if it works here. If and def type index map. Okay, this is an index of all the pixels in an image. So that way you can move on the pixels without having to do calculations every single time. Ndef. Okay, it's basically the same as sequence, but slightly different. Okay, what am I? Okay, header, yeah. Okay, type def structure index width. The width equals the size of the image. Every pixel in the image we use that's the width unsigned. That is the width of the index map. But now we need the height of the index maps. Unsigned long index height. Okay, the height of the index map is a list of all the other pixels that go into composing the result pixel. Unsigned long index length. Index length is the number of elements. Unsigned long index size. Okay, now we have the number of elements. That size is the number of bytes. Basically the same as with image. Unsigned no long. Oh, what am I doing? Unsigned long pointer index data. Okay, that's the data. Okay, now create the index. Same as always, type sequence. Let's just copy and paste this. Save us a bit of time. Okay, type index create. Type index map create. Type index map. Okay, index map parent. Width. Do we need height? I think maybe we do. Oh, maybe we don't. Length. Width height. Because the height has to expand every single time we add something, so sometimes we just do it quicker. Unsigned long data length. Signed long data length. Unsigned long length. Okay, I prefer having length closer to data length. Not necessary. Data equal length. It's same as for image. Okay, length equals width times height. Data length equals length times size of unsigned long. Data equal malloc data length. Okay, that's the same as before. Unsigned long data. White data. Oh, size of unsigned long. Okay, good. If data, we set everything to what it's supposed to be. Parent Okay, let's get rid of this. Parents dot index width equal width. Parent dot index height equal height. Parent dot index length equal length. Parent dot index size equals data length, and parent dot index data equal data. But we're not done yet. Very important, we have to clear the index first. Okay, type index clear. Okay, type def type index map clear. It's very important to clear it. Type index map. Okay. Alright, where are we? Okay, unsigned long I. Okay, for I equals 0, I less than width. Actually, width times height. Oh, we need length. Okay, I forgot about that. Unsigned long length. Okay, length. Oh. Actually, I don't need length. I already have it. Parent.index length. What am I doing? Parent.index length. I actually don't need that. I thought I did, but I don't. Okay, I++. Okay, parent.index data equal dot I equals, it cannot be 0. Okay, that's the thing, it cannot be 0. Okay, define dot const unsigned long invalid type invalid lead index. Okay, 0x ff. So it's a 32-bit value that's set to a value that's cannot be real, because we cannot set it to 0 because a 0 index is perfectly valid. Okay, so it should be up there. A 0 index is perfectly valid, so you cannot set it to that. Okay, so you have to set it to that. Okay, return 1 if parent equals 0. Okay, we have to map it here, and then as soon as you create an index map, we have to set everything to invalid. Again, it cannot be 0 parent. Okay, now we've set to invalid to an invalid value. Type index map destroy. Same as before. Come on. Type index map destroy. Okay, you don't need that. We don't need that either. That either. Go away. Okay, free. No. Parent. No, not parent. Parent dot index data. Yep, that's easy enough. Return 1. Okay, now that we have the index, let's do something with it. Oh, actually, we can't. We have to set the values first. Okay, index map set add value. Long type index map add value. We add a value into the index. Okay, we need to know the index, unsigned long index, unsigned long value. Okay. If parent equals 0, return 0. If index is more than or equal parent dot index width, return 0. Okay. Okay, where are we? We have to check I. Okay, we need to go into this specific index. Okay, J. If I is the X, J equals the Y value. J equals index. Unsigned long IJ. Do we need the J? I don't know if we do. I and J. Okay. So I and J. For I equals 0. Okay. Now for J equals 0. Is it for I equals? Yeah, for I equals 0. We go through all the values in the thing. Ji less than parent dot index height I plus plus. Okay. If parent dot index data dot j equal type invite index, then we are good. Parent dot index data dot j equal value. Okay, we go to the list of the horizontal list of values, and if one is invalid, then we set it to this value right here. We cannot expand every index independently, so we have to expand them all at once. But so we set all the others that are not right to invite values, and then we exit. And all the ones that are valid, we use them as index into the source image. Okay, I'm not sure I can explain this, but j plus equals parent dot index width. Okay, normally that would be it. But there's a special case for when the height is not big enough. Okay. Okay, if index map, not type index map, index map, okay, add a row, expand or resize. We need to resize it somehow. Okay, we need to resize it. I feel like we could use a dynamic array, but I don't like the dynamic array for this. A dynamic array is it wastes too much memory. If you're gonna do a list, it's fine, but for this, it just doesn't make any sense. Okay, add row. We're gonna have to do it manually. Parent, add a row. If parent, add a row. If parent dot index data dot j, index data dot j. Oh, okay. We'd have to do this again. That's not safe here. Add row. Okay, let's do this again. I just copied the whole code. I just do everything again. Okay. This is not the right way to do this, but return 0. Not really sure if it's the right way to do it. Just copy the code again. We do it once. We check it once, and if it doesn't, we try to increasing the size. And if it doesn't work, we try it a second time and then exit. Copying the same code twice doesn't seem right to me, but it should work. It's not elegant, but it does the job one. Okay, type index map add row. Okay, type index map. That's all we need. Okay, how do I add a row? Okay, length is same as here, I think. We just resize it, but we do it the slow way. Okay, if data. Okay, parent.index width. Parent.index width. No, parent. Index width. The index height. +1. Oh, we just reallocate. Oh, same as with the index map. Okay, that's the. Oh no, we cannot reallocate. Or can we? No, we cannot reallocate. Okay. Because we have to set the extra data to some new values. So reallocate really doesn't work the way it's supposed to. Okay, for I equals 0, I less than parent length, the full length of it, the thing, I plus plus. Okay, if I is less than parent dot index length, okay, data dot I, is it dot I or did it say? Yeah, data dot I equals what else does it equal? Parent index data. Okay, this is almost the same as reallocate, but we add a few extra stuff in onto it. Else, okay, I need to remember how to do this. Data dot I equals invalid index. Equal type invalid index. Okay, and now we free the old memory. Free the old memory, parent dot index data. Free parent dot index data. And now we set all the values to the new values. Okay, parent.index width is the same, it's still the same, we don't change anything. Parent.index height plus equal 1. Plus equal 1. Or just plus plus. But plus equal 1 is clearer. Length data, okay. If parent equals 0, copy. Okay, if parent equals 0, size of. We allocate new data length. Add row, reallocate, and good. We set everything to 1. We set return 1 or return 0 and change nothing. Okay, return 0. Okay, and I think that's it. Add a row, add value, and clear. What else am I missing? Okay, we have an extra function to add. Set value. Okay, set value. It sets a specific value to at a particular level within the index map. Level. Okay, but it doesn't add a row, just tries to set it to do the thing. Okay, if parent equals 0, we turn 0. Okay, if index is more than or equal parent dot index width, or level is more than or equal parent dot index height, we turn 0. Okay, what else do we do? Okay, we need an index. Okay, we need an index. Index I equals level, same as drop pixel, times parent dot index width plus index. Okay, and parent dot array data dot I equals value. Oh, good. So far easy enough. Return 1. Okay, unsigned long I. Okay, I have to figure this out, make sure I didn't make any mistakes here. Oh wait, J for I is not initialized. Yeah, no, I don't care. Of course it's initialized. Oh, I completely forgot about that. Okay, I did make a mistake. Oh, I made a mistake twice. Made the same mistake twice. For I equal index height. Okay, I made the same mistake twice here. Whoa. Okay, make sure we don't make the same mistake again. Okay, add a row, add everything. Okay. Okay, one more thing. Okay, type def structure. Okay, type shape. Okay, type shape. Okay, unsigned long x, y, and z. Okay, this is the idea of a tensor, a three-dimensional shape. Okay, shape is inside, long. Type shape is inside. Is inside. Type shape. Shape. Is it long? Yeah, it's long. X. Long Y. Long Z. So it's just a three-dimensional shape that we calculate is this thing inside the 3D volume. That a shape is just a 3D volume. I don't know what else to call it, but it's a simple enough name. If x is less than 0, or x is more than or equal parent. We'll have to check if parent is real here, because parent dot x, no, shape width. What am I calling x, y, z? Shape width. I'll get distracted here. Shape height, unsigned long, shape depth. Okay, parent dot shape width, or let us copy everything. Okay, x, y, z, y, and Z, height and depth. Return 1. If it's less than 0, oh no, return 0. What am I doing? If it's outside the limits, return 0, else return 1. Okay, next, shape index. Okay, shape index. Long. Type shape get index. Okay, get the index of a particular pixel inside the shape. Oh, so we multiply if shape is inside, type shape is in, the point specifies is inside x, y, and z. If it's inside, then we return okay, we have to calculate x, y, and z parent dot shape width times shape height. Yeah, we have to calculate z value, parent dot shape width. No, not shape, parent. What am I doing? Oh, what am I doing? Oh, wait. Oh, that's better. Oh, parent dot shape width time parent dot shape height. Okay, we take this part right here, we divide it into two-dimensional slices, and then the slices are multiplied by the z value. Okay, that's the first part. Okay, next, and we add parent dot shape width. No, y times, oh, the same as the x calculations. Y times parent dot shape width plus x. Is it times plus shape width? Yeah, plus shape width times x. Okay, so yeah, parent dot shape y times parent dot shape width plus x. That returns us the value. But if it's invalid, we have to return an invalid index. Okay, that should do for now. An invalid, we have shape index, shape get index. Okay, let's clean this up a bit, and then we'll start this up again later. Okay, create new file. Add a file. If and def type shape .h. Define type shape .h. And if type shape. Okay, so I just copy all this here. Well, oh wait, I didn't even save that one. Oh, this is dangerous. Okay, type shape, save it here. Save this one. Okay, type shape .h. And I'll save this one. Type index map .h. Okay. Include type shape .h. Okay, so it's mostly done. Yeah, it's getting a bit late tonight. I'll pick this up again tomorrow. So this part was mostly done. We'll see what happens later.